To go back to Dr. Kawtar Benabdelaziz. She is a senior project manager, GOPA Consulting Group. And I think I know her. She worked in Arizona. She was responsible for the electric vehicle, for the all what it has to do with batteries in Arizona. So she spearheaded Morocco's first electric charging corridor with Schneider Electric and lead electric three-wheel deployment. She's graduated from the most interesting and important school. I think if somebody is graduated from École d'Ingénieur Mohammedia, this means for us who know what it is, that she has done a very good school. That means she has a baccalaureate with a very, very high mark, and she is very smart. That's all what we know about all students. They go to this École d'Ingénieur, otherwise they will never get inside. So congratulations for you and for your work, and for the women, the Moroccan women also. And the floor is yours to talk, to give us about the topic you want to develop on electrical mobility. So thank you very much for being with us, Kawtar.
Thank you very much, Professor Anawi. Indeed, I had the pleasure and the honor to meet you 10 years ago in the Africa PVSEC in South Africa. This was our first contact.
Yes.
And there you encouraged me in my research, and I joined ICOSES 1 year later, where we developed together with Mr. Eakin and all the research team the first corridor in charging unit, as well as other smart grid research projects that we are still very proud of. And I would like to express my gratitude also for the committee for inviting me to speak today, and also warm welcome to my fellow panelists, esteemed professors, doctors, and researchers. And it's an honor to be in this panel to share my insights on the transition to electric and sustainable mobility. So thank you very much. Should I share the screen right now?
Please. Yes, please.
Okay. So do we see the screen?
Exactly, yeah.
We see the presentation, the first page?
Yes, innovation and challenge, yes.
Okay, thank you so much. So this presentation will explore the complexities and opportunities in transition into electric and sustainable transportation. So we will try today to cover key areas like the context and the challenges of the energy transition in transport, and the technology behind it, the cost structure of an electric vehicle, and also some insights from the market trends and the value chain. So first, to start with, so my presentation will be in 3 chapters: the context, the EV technology, the cost, and the market trends and value chain. So to start, the context and challenges on the energy transition in transport. As you may all know, what's going on is the climate change, and I don't think that I need to talk much about it since everyone knows the problematic today. If we look very quickly at the graphic, this is the worldwide emissions from 2015 to 2024, and we were already at 57.1 billion tons in 2023, and we are supposed to reduce our emissions to at least this graphics, but unfortunately, in the way we are going, we are still emitting and polluting too much for the planet. So the electric mobility and sustainable transport in general is shown as one of the solutions, since the transport is accounted than more of the third of the emissions in the energy modules. So in terms of the ambitions, the majority of states in the world seems lucid I would say, about the importance of this reduction. 101 parties represent 107 countries and covers about 82% of the global GHG emissions in the world. And they have already made commitments to this net zero emissions in more or less long term. So for example, for the European Union, we are in 100% in 2050. In the latest news, even though there is a huge work from the automotive lobbying to reduce these numbers. 2016 for China, that represents already 70% of the worldwide sales. And then for example, for the market share, United States only represent 8.9%. In the case of Morocco, we ambition to replace 30% of the state fleet, but there is no official numbers about it. And what we can say about this commitment is that the implementation of the actions is too slow, as far as we know. At the international level, the solution of this mass pollution is the electrification of transport as an effective and very concrete response to reduce the footprint of the transport sector. But is it really a miracle solution? This is what we are going to see. So why do we talk about electric mobility? So obviously there is a climate issue, and we must decarbonize the road transport, because in the energy module, it's accounted for more than 70%. But in the same time, are we really able to electrify all the fleets? In Morocco, that is in the same path, because it confirms, the numbers confirms the same path that we see in an international level. 26% of the emission of the transports in the energy modules comes from the transport, and 1.6% of the GDP is on the cost of the air pollution. And we have only 4.2 million vehicles on the road. As an example, in Germany, it's 40 million for 88 million people, while it's 4.2 million in Morocco for 40 million people. So we can see that it's not a lot of vehicles, but still, we know that the growing of the automotive market in Morocco is by 6% every year. So we can see from now that there will be a problem in the future. So, for example, I can give the case study of France in terms of regulation. In 2021, we had the Accord de Paris at international level. And then it was declined as a European level as the European Green Deal. And at the national level, the French National Low Carbon Strategy have been published in 2015 before the COP, and resulting from the energy transition to the Green Growth Act, it aims to meet the commitments made by France at 2021. So this strategy is based on a roadmap, which is the part of this global context to fight against global warming. And the main objective is the reducing the carbon footprint of consumption and achieve carbon neutrality by 2050 in France. So this added to the 70% reduction in GHG emission from the transport sector by 2015, designed that the technologies for vehicles that will be put in the markets in 2030. So who are gonna be still in the roads in 2050. So we can see that the efforts, even with the regulation, seems very huge. But the problem of electrification is that we see it as one solution. But what's happened in the French regulation is that we have standards that recommends decarbonizing with electric vehicles, but we need to be aware that beyond these engines, there is an entire ecosystem around electric mobility that must be transformed, which means that decarbonizing the transport doesn't mean electrifying all the fleets, because it requires a reduction more in mobility needs, increase in non-pollution means of transport, like bicycles, like adding more buses, etc., and put in a transport system that can finally make us able to electrify the rest of the fleet. Because the problem with the private vehicle is that there is a great demand on the public space, and if we measure this in relation to the modal split in cities, it occupies an excessive areas. So the road and public transport are reaching a capacity, and commuting seems to be a matter of course today with all the technologies that we are using. For example, having this conference from Germany while it is in Morocco reduces a lot of transport emissions. So it's also one of the solutions that needs to be put on the table when it comes to thinking about decarbonizing the transport sector. So cycling, bus systems, etc., in the way we design our urban areas and cities, but also how we think about peri-urbanizations of jobs and not having everyone coming from around the city to the center of the city. It's also a matter of designing our cities and our new ways of mobility. There is another question behind it. It's the energy efficiency of the different mode of transport. Also, if we look at from this perspective and we compare the energy efficiency of the different modes of transport, the private vehicle is one of the most energy intensive means. So if we want to reduce energy consumption, we need to reduce go into directly to the private cars. So if we see the photo on the left, it shows the space consumption of a car, and it shows the aberration of the society, how in the automotive system. So in the cities, there are public spaces that are taken too much by the cars, while we can see that from the same unit of area, it is possible to circulate 4.5 times more people by public transport, by bus, and 7 times more people by bicycle, and nearly 10 times more pedestrians. So to finish this first part, there are 5 key messages about electric mobility that I would like to present. First, that electric mobility is crucial, but it must be part of a holistic approach where we think about transportation in general. And it's more than just private cars. There are also electric taxis, sharing systems, urban logistics, public fleets and commercial fleets, public transport, and also 2- and 3-wheelers. Also, the higher the share of renewable energies, the better will be the impact of electric mobility. It reminds me of a story when we were at ICOSES and we tried to help the Teslas charge between Marrakesh and Berlin for the COP23, I think, or something like this. And we didn't have enough capacity on the grid at that time to have multiple charging units. So we were obliged to get a diesel generator to generate electricity. And we have seen, like in front of us, what does it mean to have a non-decarbonized grid that charges electric cars? So if you don't take the whole value chain of this car, you are not doing really electrification and reducing emissions. It needs to come also from the share of renewable energy in the grid. Also, introducing electric mobility requires also new cooperation and partnership, and this is what we are going to see also in the rest of the presentation. And it produces also multiple co-benefits. It's not only reducing emissions, but it's also reduction of noises in the cities, the dependence on fuels and fossil energies. There's also new economic opportunities and also the air quality. So let's dig down a little bit more into the technology of electric vehicles and the structure of cost. So there are advantages and current, I would say, disadvantages for the electric vehicles. There are key components of the decarbonization, and their large-scale adoption remains a little bit hampered by few obstacles. So if we see the advantage, of course, we know the reduction of CO2 emissions. It's also a cheaper travel cost. Electricity is cheaper than the fuel, at least in the current context. The energy consumption is also less. And because of some regulations in some countries, there are lower parking, but also maintenance costs. And we will see this, it's also related to the engine. I would say the disadvantages will be the density of the charging infrastructure. There is not enough anywhere, apart in China. The battery cost still, it's 1/3 of the whole price or the cost of the vehicle. The limited battery life, a battery has a life that also depends on multiple parameters, and also a high charging time. At that point, we have also fast chargers, but we cannot really compare it to charging by fuel a car that takes some minutes. So it's not really comparable at this stage. So if we look at it as a system, the electric vehicle is what we call a mechatronic system. We're specifically looking at battery electric vehicles, which are more environmentally friendly than the hybrid counterpart. And I don't think that I'm going into this debate, but if we peel the EV together, It consists of parts that are common of all cars, such as the cockpit, so the passenger compartments that integrate the thermal comfort system and aerodynamics, the transmission system that includes the wheels, the differentials, the chassis, etc., the powertrains, and the traction chain that is different than the other cars, which is where you have the power generators and whose battery plays the role of a fuel tank. So if we look more deeply on this, we understand that the most problematic thing in the electric vehicle is the battery. So indeed, like any chemical system, the problem of this battery is that it's subjected to aging. So predicting the aging evolution of a lithium-ion battery is a major challenge in electric vehicle application. I don't know why I don't have the... normally in the presentation, I had the parameters, but anyway, we can just talk about it. There's a problem in my slide. So the battery, the aging of the battery depends on multiple parameters. It depends on the way we drive, the way we charge it, the way we discharge it. So this is also in the driving cycle. And also on the temperature, the ambient temperature. And we are going to see this also together. One between brackets, we can also speak a little bit about the hydrogen vehicle, what I call the good bad idea. So it has a low energy efficiency, and there is a lot of questions related to its energy sources. As you may know, the hydrogen, there is many colors of hydrogen. We speak about green hydrogen as a source, but the prices, the production, the transport of this hydrogen is still subject to a lot of discussions. From the point of view of some of researchers and experts in the domain, the hydrogen vehicle will be reserved for application where the EV will not be able to meet the needs. Like, for example, a very long distance, places where we don't have charging opportunities, etc. So the main difference is that in the electric vehicle, we use batteries to store the electricity, and it powers the electric motors, while in the hydrogen, we use a fuel cell to convert this hydrogen into electricity, and then powers the electric motors. The energy efficiency in an electric vehicle is approximately 70% and up to 90s, while in a hydrogen vehicle, the overall energy efficiency is approximately 30%. So if we look into the engines, the electric motor is less maintenance, is easier, it's less expensive than to produce also than the combustion engine. It's a matter of how it works. So an internal combustion engine needs more than 2,000 mechanical parts, while in the electric motor we only need 20. The oil and exhaust system needs to be replaced periodically, while in an electric motor we have electromagnetic forces and not a lot of mechanical parts. And we don't have regenerative braking, of course, because this is specificity of the electric motor. And the battery remains the most critical part because it needs to be replaced every 10 years on average or more. It depends on the way you use it. And it's also connected and can provide information on its status. The most critical question about the battery is about the rare materials needed to produce the electric motors and the battery. So it's an issue that is, I would say, being resolved. For example, in electric motors, there are some magnets that are made with materials that can come from more than 90% from China. So it's the rare materials, and manufacturers are therefore dependent on Beijing and its control over exports and prices. And in addition, there are the large CO2 emissions linked to the extractions of these materials that can also cause us a problem and questions. And to compensate for these dependencies and costs, some manufacturers have embarked on the production of rare materials motors, like Tesla, BMW, Toyota, and General Motors. And in 2023, for example, Tesla had managed to reduce the use of rare materials in the new propulsion units of the Model 3 by 25%. So manufacturers are working on it, but it's still one of the problems. So I think my slide have came back. So what we talked about was the depth of charge, charge in power, charge discharge cycle, and the driving cycle, and the temperature. So one of the most big problems of the battery is the aging, and the aging is closely related on the temperature. And my PhD thesis was about this, so you can also find some papers about what we did as experimentations and calculation. So in this temperature, why? It's because according to the Arrhenius equation that describes the variation in the rate of a chemical reaction as a function of temperature, we can see that the temperature affects the battery pack. And we can see here in this graph that the range achieved by an EV on average compared to its range at a given temperature changes. So the best temperature to drive an electric vehicle will be 20 to 25 degrees, where you have like the maximum of autonomy. And if in the cold, the autonomy decreases, when it's hot or when there is some internal temperature rising, and if there is any other kind of problems, the autonomy will decrease in an exponential level. So most of EV owners exceeds the vehicle's standards range under peak temperatures condition, but when you rise or lower it, the loss of autonomy is completely obvious. So at minus 15 degrees, as you can see here, we can only get 54% of the standard range. And what that means is that if you have a range of a car of 400 kilometers, you can only travel with it 200. And if this cold weather impacts EVs most of the time in Europe, heat is worse, because if we look in more details, the ranges decrease faster. And in real-world conditions, the impact of hot temperature can be less than European countries. But if we think about Morocco and more south countries in Africa, it's likely to happen and to have a negative impact in the EV. So even though the manufacturer didn't think much about it, but there are cooling systems within the cars, also for matters of security. And also we can see in cars for the United States markets, more developed cooling systems. So they provided thermal management systems for the battery, but all the cars does not have the same system or the same efficient system. Because, for example, if you see that in the Tesla, you have a liquid cooling in the Tesla Model S, most American cars that are quite expensive, which is not the case for Ford or for Renault, because they have a cooling system that is more archaic and that use only air. So potentially, this non-expensive cars could potentially experience more excess temperature during their life.
5 minutes.
Okay. So I will not look at what the research focus on the batteries. It's also a matter of research on the different densities of the batteries. And there are also many other electrochemical couples than lithium ion that we know. There's nickel cadmium, nickel metal, nickel zinc, sodium chloride, etc. And the researchers are focusing on that. I think I will pass the questions about the charging. This you can also have more information later. But if we think about some of the most important question, like can we charge a car in 9 seconds thanks to the new technologies? It is true, but the batteries will suffer from it, including health. They will have health problem and needs to be changed very fast. Do we need an EV that has more than 1,200 kilometers of range? Not really, because most drivers use between 300 and 400. And still the question of inductive charging, it suffers from also energy losses. So this all can be a very good questions for researchers in the future to look for it. I wanted to see also the total cost of ownership of an electric vehicles that is related to this lifetimes, including purchases. But if we look very quickly to the costs, so you can see that it depends on the ventilation of the cost, and that an electric vehicle can be more stable and have a better, I would say, TCO in the future, depending on the regulation and depending also on the charging behaviors. When we were at ICOSES, we did a very interesting comparison between the prices that you can also find in the internet. My last presentation would be on the market trends and value chain. It's not a secret for anyone, but China dominates the electric vehicle market, and it's seen as a very recent phenomenon, but it has roots in a very good industrial strategy combined with some mistakes, quick adjustments, and massive, very massive government support. So the role of the government have been a big key in China's success in the EV sector. Quickly, I will just say a word on the value chain of the electric vehicle. So the electric vehicle in itself is shaking the automotive industry value chain with very new links such as energy services, battery, and intervening at different level of the whole value chain. And if we look at the China's dominant electric market, we can see that with more than 14 million electric vehicles produced and 17 million expected, more than 17 expected last year, there is a mass growing production in the world dominated by China. But it didn't come from nowhere. It was a very big strategy since 1985 that results in this combination of rapid learning and technological innovation, but also the strategic government support. So if you look at it from a macroscopic point of view, China have made financial incentives. They have invested massively in rare metals and rare materials. They have a tendency of overproduction in general in the industry, and electric vehicle production is also part of it. And they also continue research and also innovation, advances in digitalization, in battery, and in autonomous driving that makes their cars today going up than any other manufacturers in the world. So last slide to resume what we said about the challenges of this transition in electric vehicle. There are, of course, challenges, but that kind of represent also opportunities. The environmental issues, the battery life cycle that addresses the extraction of raw material like lithium, cobalt, and nickel, the battery manufacturing, the recycling, the potential of environmental impacts of this, and the efforts of more sustainable sectors. There's also economic issues in the cost acquisition and cost of use, and we can think about new business models, the development of charging infrastructure, and also the job creation and developments of new sector, but we're thinking about international competitiveness. Also, the social issues would be affordability, the social acceptance, and the spatial planning and mobility of our cities and future cities. And at the end, also technological challenges. So more work on range and charging times, on the battery performance and the reliability of these batteries, and also everything around innovation and research, because it's important to develop and improve existing technologies and exploring new ways for this energy transition. So thank you very much for your presence, and I am open to questions, and also you have my email address for any inquiries. Thank you very much.